our next point for the discussion is that effect on the discharge over a notch due to the error in the measurement of the head. So we have to understand this particular point, that measurement of q accurate measurement of the q is again depending upon the actual assessment, or you can say a precise assessment of head over the weir. Assessment of the head over the weir. Why it is important? If you look at this value of q, this value of q is proportional to the h raised to the power 5 by 2, and similarly q is proportional to the h raised to the power 3 by 2 in case of the triangular and rectangular notches respectively. This is triangular shaped notch and this is valid for the rectangular shaped notch. So if you look at this equation, this is very much clear that if you occur any error while measuring the head over the weir, then you are again introducing some error in order to assess the actual discharge. So let's discuss how we will assess such things. So first of all, let's take the case of rectangular weir. So discharge equation that can be written as q is equal to 2 by 3 CD multiplied by L multiplied by under root 2g multiplied by h raised to the power 3 by 2. So we can say that this particular term is just a constant. So simple equation, if we just writing that this is k which is a constant, so this we can write that k multiplied by h raised to the power 3 by 2. So if we write this thing that q is equal to k h raised to the power 3 by 2, and if we are differentiating this particular equation, so this after differentiation this will look like that dq is equal to k multiplied by 3 by 2 h raised to the power 1 by 2 dh. Now if we just divide the equation 1 and your equation 2, so we can write it as that dq divided by q is equal to k 3 by 2 h raised to the power 1 by 2 dh divided by k h raised to the power 3 by 2. So we will get that this is 3 by 2 dh by h. So we can write that thing that dq by q is equal to 3 by 2 dh by h. So this is valid for the rectangular shaped domino. So this particular term will give you the error in the measurement of, or you can say relative error in the measurement of the head over the weir. So this dq will give you the error in the measurement of the discharge introduced by the error occurred during the measurement of the head over the weir. So you can just say that if we are getting 1% of error in the measurement of dh, let's say dh by h is somewhat, let's say this 1%, then dq by q will be equal to 3 by 2%. So you can see that this is getting amplified. So whenever we are measuring the head over the crest, we should be very careful. Similarly, in the view of the previous discussion, if we go for the measurement of the effect of discharge over the triangular notch due to the error in the measurement of the head, so similarly we will be getting an equation of dq by q is equal to 5 by 2 dh by h, because the discharge is directly proportional to the fifth 2.5 power of the h. However, I'll just demonstrate you that how we will conclude this, or how we will get this particular expression. So if we go for the triangular notch, so the expression we used for the assessment of discharge, or actual discharge for the triangular discharge, is 8 by 15 CD multiplied by tan theta by 2 under root 2g h raised to the power 5 by 2. So if you look at this thing, this particular thing is going to be constant. So we can straightforward write at q is equal to k times of h raised to the power 5 by 2. So this is your equation. This is your equation 1. And if we differentiate q with respect to capital H, so this will be dq is equal to k times multiplied by 5 by 2 h raised to the power 3 by 2 dh. So this is your equation 2. And if we divide the equation 2 by equation 1, so this will look like dq by q is equal to dh by h. So now if we say again, this uh, dq by dq will be 5 times of dh by h. That means if we are occurring a 1% error in the assessment of the discharge over the Weir, then dq of this will be 5.5 by 2%. So this is important that when you are using any triangular notch, you should be more careful, because this is a very sensitive, that is 5 by 2 times in comparison to the 3 by 2 times when we are using the rectangular notch. So our next problem is based on the estimation of the error in the discharge due to the error in the measurement of the head. So the problem says that a rectangular notch which is 90 centimeter long is used for measuring a discharge of 120 liter per second. An error of 3 mm was made while measuring the head over the notch. So we have to calculate the percentage error in the discharge, considering that CD is equal to 0.6. So if we start with the solution, so what exactly we find out that the L value on the length of the notch is given as 90 centimeter, that is 0.9 meters, and Q is given to us is 120 liters per second, that is 0.12 meter cube per second. And so the error in the head is, that is dh. dh is 3 mm, that means 3 into 10 to the power minus 3 meters, and the CD value which is given to us is 0.6. So the first of all we will find out the what is the H. So Q is equal to 2 by 3 CD multiplied by L multiplied by root 2G H raised to the power 3 by 2. So Q is equal to 0.12 multiplied by 2 by 3. CD is 0.6, L value is 0.9, and under root 2 multiplied by 9.81, and h raised to the power 3 by 2. So from this equation we can figure out the value of the h, that will come out to be 0.178 meter. So we already have the dh. So for this we have already derived that dq over q will be 3 by 2 times of dh over h. This is valid for the rectangular notch. And when this problem is for the triangular notch, this 5 by 2 will be equal to 3 by 2 will be equal to 5 by 2. Now, so the dq over q will be dq over q will be 3 by 2 multiplied by dh. We have find out this dh value is 3 into 10 to the power minus 3 divided by h value is 0.178. So this is coming out to be 0.025. So if in percentage we can say that dq by q is equal to 2.5%. This is our answer. So let's again solve a problem which is similar to the our previous problem, where the instead of the rectangular weir we are going to use the V notch. The problem says that a right angle V notch is used for measuring a discharge of 120 liters per second. An error of 3 mm was made while measuring the head over the notch. Calculate the percentage error in the discharge when taking the CD value of 0.6. So let's go for the solution. So that comes out to be, so this is I mean right angle V naught, so theta is equal to 90 degree, and q value is given to us, that is the 120 liter per second. That means 120 meter cube per second. The error while measuring the head over the notch is 3 mm. This is 3 multiplied by 10 to the power minus 3 meter, and CD value is 0.6. So similarly, let's assume that the head over the notch is h, that we have to determine. So the formula we use for the triangular notch is 8 by 15 CD multiplied by tan theta by 2 multiplied by under root 2g h raised to the power 5 by 2. So let's put all the values. 8 by 15 multiplied by 0.6 multiplied by tan theta by 2 will be 1 multiplied by 2, 9.81 multiplied by h raised to the power 5 by 2, and here it is 0.12. So h will be equal to 0.3724 meters. So now we are aware that how much dh is available. So similarly for the triangular notch, we can write that dq over q is equal to 5 by 2 times of dh over h. So that is 5 by 2 multiplied by dh is 3 mm, and here it is 0.3724. So this is 372.4 mm. So this value will come out to be 0.020. So in percentage, dq by q in percentage is 2.0. So let's take an interesting problem related to the error in the discharge due to the measurement of wrong value of the head. So the problem says that head of the water over a triangular notch of angle 60 degree is 100 centimeter and the coefficient of discharge is 0.6. The flow measured by it used to be within an accuracy of 3% up or down. That means 3% plus or minus. So find the limiting values of the head. So let's go for the solution of this particular problem. So theta value is given, that is your 60 degrees. H is your 100 centimeter, that is 0.1 meter, and CD is 0.6. So the error which we are allowed to occur in the measurement of discharge is 3%. So that is dq by q is equal to 3%. So we can write it as plus minus 0.03. So we are aware that for the triangular notch q is equal to 8 by 15 CD multiplied by under root 2G tan theta by 2 h raised to the power 5 by 2. So if we put all the values, this is 8 by 15 multiplied by 0.6 under root 29.81 multiplied by tan theta by 2 will be tan 30 degree, and h value is given to us, that is 0.1. So 0.1 raised to the power 5 by 2. So if we calculate, the Q value is coming out to be 2.5878 meter cube per second. That is the Q value. We are already aware that dq over q for the triangular notch is 5 by 2 times of dh over h. So already we are aware that dq over q is allowed, that plus minus 0.03 is equal to 5 by 2 dh. dh is dh that we have to determine. So dh divided by h is equal to 2.5878. So the dh is equal to 0.03 plus minus multiplied by 2 divided by 5 and then multiplied by 2.5878. This is 3.10 10 to the power minus 5. So dh is this much meter. So we can write it that in the terms of the centimeter. So this value will be 3.10 10 to the power minus 2 mm. Or we can say that it is 0.310 meter. That is the value of dh. So the allowable head, that will be equal to the allowable head will be equal to h plus minus dh. 0.1 meter, so 0.1 meter, then plus minus 0.0310. So this value will be coming out to be either, so this value is coming out to be either this value if we take the plus sign, or this value if we take the minus sign. So if you see, this particular value is coming out to be when we are considering the plus sign, and this value is coming out to be this side. So our answers are that 0.1310 meter and 0.069 meter. That is the limiting values of the head. For the maximum and minimum values of